Okay, before we move on to new material, I did want to briefly review trusses as well because, well, I have no idea कि हम assessments or exams वगैरह किस तरह करेंगे, but trusses are indeed one of the things that can be, solved with pen and paper. So इस वजह से मेरे हिसाब से थोड़ा सा stress इनके ऊपर देना चाहिए from an exams point of view. Conventionally, at least. Okay, so trusses the kya? They are just members, axially loaded members that can be oriented along any angle other than 0 degree, right? So जो हमारी simply axially loaded beams थी, sorry beams नहीं थी, bars थी, उन पे तो load भी उसी direction में ही होता था कि जो कि उसकी x direction होती थी, and everything was in a straight line. It was a 1D problem essentially. ठीक है, but if we got like arrangement of these axially loaded members and different angles, then you've got like a structure which can just each individual member can only be in compression or tension, so it does behave within its own coordinate system like a simple axially loaded member जिसका वही AE over L type की stiffness matrix है. But now you got this added complication that there are some angles to think about. ठीक है, so they can only be in tension or compression. Is point of view say they are just as simple. The only problem is now that we also have to think about some coordinate transformation. ठीक है, so इस पे एक सादा सी coordinate transformation पहले तो दिखाई हुई है कि if you're moving from a coordinate system x to y, sorry xy to another coordinate system capital X capital Y कि जिनके बीच में there's an angle theta, then you can come up with is a transformation matrix that moves from capital UV to small uv, and this matrix is that transformation matrix. इसका आप inverse भी ले सकते हो to move from the to move the other way around, right? हमारे केस में हमारा जो सिस्टम है वो थोड़ा सा डिफरेंट तरीके से लिखा हुआ होगा. You've got an undeformed truss 1 2 and a deformed uh, you know जो कि after deformation इसके x direction में deformation is q1, y direction में is q2 for node 1, और x direction में deformation for node 2 is q3, and y direction में deformation for node 2 is q4. ठीक है, so ये q1 2 3 4 are the four nodal displacements of this element in the global coordinate system sort of. और इसके जो local coordinate system है उसमें you only are concerned with two different deformations, the deformation of node 1 which is q1 prime या dash, and the deformation of node 2 which is q2 prime या dash, जो मर्जी कहना है इसको आपने. ठीक है, so थोड़ी सी इसमें trigonometry involved है to find a relationship between q1 prime and q1 q2. Not that difficult really. If you got an angle theta between the positive x axis, say clockwise, sorry counterclockwise positive, अगर आप if you move counterclockwise positive to the actual angle of your truss, that's your angle theta. So just looking at this picture, this q1 prime can be broken down into two parts, a part from here to here, right? So this part is just going to be equal to q1 ka cosine theta, right? And then a second part from here to here, which is going to be q2 का sin theta, right? So similarly, आप इसके साथ भी इसी तरह का सलूक कर सकते हैं कि q2 prime can be thought of as having two components. One is one component from here to here, which is going to be q3 cosine theta, and another component from here to here, which is going to be q4 sine theta, right? And just add them together to get the other coordinate. ठीक है, so इसकी base पे you can come up with a transformation matrix which is going to be called lambda, and you can just take an inverse of that transformation matrix as well if you want to move from depending on which direction you want to move from q to q from q to q prime or from q prime to q. ठीक है, इसमें notation कुछ इस तरह की है कि L is so called the direction cosine. L and M are the direction cosines of the truss, which is to say it's the cos of the angle it makes with the x-axis. L basically is the cos of the angle the truss makes with the x-axis. M is the cos of the angle that it makes with the y-axis, or just sine of theta in this particular case. मगर ये वाली terminology direction cosine वाली मैं इस तरह से इस्तेमाल कर रहा हूँ कि इसी तरह एक तीसरा n भी हो सकता था, which would have been the cos of the angle that it makes with the z-axis. ठीक है? But for our simple case, L is just equal to cos theta and M is just equal to sine theta. ठीक है? So for a 2D element, this is your transformation matrix lambda. You can also take its inverse. और जब हमें ये lambda निकल आया तो उसके बाद if we know the local frame of reference के अंदर local coordinate system के अंदर if you know the k, then you can find the k in the global coordinate system. By just noting k, the strain energy remains the same in either of the coordinate system. ठीक है? So the strain energy अगर मैं small k के हवाले से लिखूं तो this is what it looks like, और अगर मैं this is for local coordinate system, and if you're looking at the global coordinate system, this is what it looks like, and they have to be both the same. Coordinate system से strain energy पे फर्क नहीं पड़ने वाला. ठीक है? So जो conversion थी local और global के बीच में, जो conversion थी, if you just plug it in to the definition, um, you know, where do you want to plug this in? You want to plug it in here, right? If you plug this in here and then just do a comparison of the left hand side and the right hand side, you can say that this whole thing should be equal to k in the global system, right? So this part is the global system and this is the local coordinate system. ठीक है? So 2D के अंदर अगर आपने k निकालना है तो this is a couple of matrices that are just multiplied together. This was, remember, this lambda was 2 by 4, right? So lambda transpose is a 4 by 2. ठीक है? So since lambda transpose is a 4 by 2, the overall 4 by 4 matrix बन जाएगा. You can just ask MATLAB or something to do this calculation for you. Of course, this result is directly already available in the formula sheet anyway. There's a formula sheet. I think that was obvious enough, right? अगर exam जिस मर्जी style में हुआ, कोई ना कोई formula sheet लाजमी होगी. I'm not gonna ask you to remember this in any case. ठीक है? So this is the K to use for any truss that's at an angle theta, कि जहाँ पे this L is just going to be equal to cos of that theta and this M is just going to be equal to sine of that theta. Okay. So space trusses वगैरह के बारे में तो बिल्कुल भी बात नहीं करनी, अलबत्ता यही ट्रसेस से रिलेटेड, सॉरी हाँ ट्रसेस से रिलेटेड किसी होमवर्क जो प्रैक्टिस प्रॉब्लम्स थे, जो कि बाय द वे आई हैव अपलोडेड दिस होल सेट एज वेल, हैव अ लुक एट इट, इट्स गॉट लॉट्स ऑफ प्रॉब्लम्स. इनको ब्रीफली देख लेते हैं बिकॉज वी डिड दिस इन क्लास, सो दिस शुड नॉट बी एन इशू फॉर मोस्ट ऑफ यू. सो व्हाट वी हैव हियर इज कि हमारे पास 1, 2 और 3 एलिमेंट हैं और उसी के साथ 1, 2, 3, 4 नोड्स हैं, राइट? और हर नोड्स के 2 डिग्रीज ऑफ फ्रीडम एक्स और वाई हैं. सो आपके पास ओवरऑल जो ग्लोबल स्टिफनेस मैट्रिक्स है, दैट्स गोइंग टू बी a 2 multiplied by 4, यानी कि 8 by 8 का मैट्रिक्स. ठीक है? So what we want to do is first we want to find the stiffness matrix for each of these individual elements, right? So find 3 of these individual KEs and then assemble them and then apply the boundary conditions, which basically is K 0.2, 3 or 4 पे both U and V are 0. Yeah, displacement in X and Y are both equal to 0 because it's fixed. ठीक है? So 6 out of these 8 nodal coordinates are actually equal to 0. So the only thing that's left is this coordinate 1. Coordinate 1, node 1, sorry, node 1 पे जो X और Y की motion है, that is not indeed constrained. So that's the only thing we are actually going to be solving for. Okay, so you can look over this entire solution. Of course, the first thing is that we do is find K for each of these individual elements and then write them in this form कि जिसके ऊपर जो है ना ये जरूर लिखना है कि यार ये for example, element K1 corresponds to stiffness matrix of this one element, and this is acting between your node 1 and node 2, which which have these corresponding displacements u1 v1 u2 v2, right? So ये सिर्फ बता रहा है कि हमने global stiffness matrix में इसको किस जगह पे उठा के plug in करना है, right? The numbers, sorry, the notation on the top and on the side is just for that purpose. ठीक है? So similarly, K2 is between these nodes 1 and 3. So यहाँ पे इसी तरह appropriately u1 v1 u3 v3 लगा लिखा हुआ है. You do the same thing for K3, create the entire global stiffness matrix जिसमें 1 2 3 4 1 2 3 4 सारा कुछ है, and then get rid of everything except u1 and v1, right? और दूसरी साइड पे एक फोर्स का जो मैट्रिक्स जो वेक्टर बनेगा, that is kind of very straightforward. There's just minus 40 kilonewton force and in the y direction, right? So that's going to be applied to ये v1 wala coordinate, right? You can take an inverse of this thing, find u1 and v1, और उसके बाद if needed you can find the stresses by a couple of ways जो कि चलो maybe we'll do later on as an example. ठीक है? I'm gonna stop recording here. उसके बाद we can move on to beams and new stuff.